In here, you're asked to find the least possible degree of each polynomial. On the first problem right there, it looks like you have 4 roots, but something we cannot forget is that the irrational roots come in pairs. So what that means is that the irrational conjugate, which is the negative square root of 5, is also another possible root. So in here you have 5 possible roots. So the least possible degree of this polynomial here is 5. So a 5th degree polynomial. On this other one, same idea with the imaginary roots. So imaginary roots, let's not forget that they come in pairs. So another possible solution would be 11i right there. So we have 1, 2, 3 possible roots. So in here we would get a 3rd degree polynomial as the least possible degree. This one down here is a little different. So in here, the least possible degree of the polynomial is basically the degree after we expand the polynomial. So it's the degree of the leading term, which means it is the highest degree. X cubed times x is x to the 4th. X cubed times 5 is 5x cubed. So this is a 4th degree polynomial. So the least possible degree is 4th degree. But if you don't want to expand it, what you could also do is look at the multiplicities of each factor. Like this factor here has a multiplicity of 1. This factor, x is also a factor itself, has a multiplicity of 3. So if you have the multiplicities 3 and 1, you get 4. So that also tells you that it's a 4th degree polynomial. But that only works because the x term in this factor has a power 1 and x has a power 1 in there. Now let's look at this one. So this one, it would take a long time to expand this out. You would have to multiply, you can distribute, use box method, but we could just analyze the structure of the polynomial here. The polynomial here is in factored form. So what we can do is we can look at the multiplicities of each factor. This factor has a multiplicity of 2. This factor has a multiplicity of 1. And because the x terms in each factor are linear, have a power of 1. So what that means is that basically if you add the multiplicities of all together, so 2 and 1, so that tells you that's a 3rd degree polynomial. So adding the multiplicities together, so the multiplicity of this factor plus the multiplicity of this factor, which are 2 and 1, gives you a total of 3. So the least possible degree in here is 3rd degree. But that only works because the x terms are linear. And now right here we read the graph. So in here you have to analyze the graph, what's going on at the root. So this graph right here has a total of 1, 2, 3 distinct roots. Distinct roots are the ones you see in the graph. At the x-axis here, the graph bounces. So the graph bounces off the x-axis. So something we noticed in class is whenever the graph bounces off the x-axis at that root, we have an even multiplicity. And we're talking about least possible degrees right here. So the least possible multiplicity for this root right here is a multiplicity of 2. Now right here, the graph crosses the x-axis. And we learned in class that whenever the graph crosses through the x-axis, we have odd multiplicities of that root. So in here, the least possible odd multiplicity would be 1, because we're talking about least possible degrees. And again, the graph crosses through the x-axis at this root, and our least possible multiplicity is 1. That's because whenever the graphs cross through the x-axis, we have odd multiplicities, and the least possible multiplicity is 1. So in here, our least possible degree is all the multiplicities added together. So 2, 1, and 1. So 2 plus 1, that is 4. So our least possible degree for this polynomial is 4th degree.